One of the things that we need in order to better manage brown marmorated stink bug in agricultural crops, and in particular tree fruit crops, which are at high risk from BMSB damage, is a really good monitoring tool that would allow us to detect the presence, abundance, and seasonal activity. So in terms of the bug's biology, we found that this insect across many cropping systems is a border-driven pest. And what that means is it invades crops from the outside. So in order for us to detect that movement, we needed to develop a monitoring tool for brown marmorated stink bug. We began first with some of the trap designs we've been looking at, which was a trunk mimicking trap stimulus, these so-called black pyramid traps. We also had initially a single attractant known as methyl decatrienoate. Unfortunately, this attractant, although it's very effective in the late season for brown marmorated, we couldn't use it season long. So several years ago, we were able to identify the pheromone of brown marmorated stink bug. And what we found was the pheromone of brown marmorated stink bug in combination with this methyl decatrienoate stimulus provided a very attractive and sensitive season-long lure for our traps. With our traps, one of the best studied systems is apple orchards, because this has been one of the crops that has been most heavily affected by brown marmorated stink bug. And so now that we have a season-long monitoring tool that we can accurately detect the presence of bugs in and around apple orchards, the next step is then to take the numbers of bugs showing up in those traps and translate that into information the grower can use to make a good management decision. So in this case, what we have found is that over the course of what could be several weeks, the accumulation of bugs means something. And in this case, what we've seen is that 10 adults per trap essentially translates into a point when the grower needs to take some sort of intervention and perhaps spray an insecticide. What we've seen is that compared with weekly applications, using this threshold, we can reduce the number of insecticides applied against brown marmorated stink bug by about 40%, but protect the fruit in such a way that it was just as good as if they had treated the orchard weekly. For the grower, it means that not only it saves them money because they're spraying far fewer chemicals and using far less fuel, but also it increases the likelihood and the ability to maintain our natural enemies in and around our orchards. We're reducing our broad spectrum materials against brown marmorated stink bug. And of course, this is one of the types of tools that we need to provide us with the ability to bring back our integrated pest management programs. And so Apple has been really a good model system for that endeavor. So one of the things we've been able to learn about the brown marmorated stink bug aggregation pheromone and synergist is the use of these two stimuli to manage the bug. We've been able to demonstrate that we can use these stimuli in traps and reliably detect their presence, but in fact, we can use these two stimuli at higher doses and bait select perimeter row or border row apple trees and aggregate bug activity in those trees. What that means is the bugs are then not dispersing throughout the entire orchard block. And so for a grower, they can treat just those single baited apple trees and leave the remainder of the orchard untouched. So in other words, you're reducing the amount of insecticide being applied against brown marmorated stink bug by over 70%. So over the last several years, we've certainly been able to begin to develop IPM tools for brown marmorated stink bug to enable growers to manage this insect more sustainably in crops. But ultimately, in order for the threat of this pest to be really mitigated, we really need a long-term solution. And that long-term solution is based on biological control, both from our native natural enemies and potentially through a classical biological control program.